Everything around us is being designed and manufactured, including our household products, the food that we eat, the buildings, hospitals, the roads, vehicles and infrastructure around us. And the research we undertake as a group really impacts across all of these areas.
The research that I do is intelligent or smart manufacturing. That is when products and machines decide what's an effective way of making things and how systems of human beings and artificial intelligence will work together to produce customized products very efficiently and very quickly. It relies heavily on manufacturing engineering, but also computer science and artificial intelligence. Sociologists and economists are also involved. I collaborate with Renishaw, Autodesk, Rolls-Royce, and also people who create the machinery and the software for next generation of manufacturing.
We have a very interesting collaboration at the moment with the Computing Science Department, which is aptly named LegoCAD. And this is about adding physicality back into design activities and design process. So what we're doing with our colleagues in computing science is to actually create construction kits, so very advanced construction kits, and using those in combination with digital models, so things like results of simulation and projecting and combining the two, which ultimately is about accelerating the design process. But really importantly, what we found is it's absolutely a key enabler in getting citizens and users involved in the design process. So some work we're doing at the moment with Knowle West Media Centre is about allowing citizens to co-create and co-design future housing areas and housing designs in the regional locality.
3, 2, 0, and lift off.
I work on model-based systems engineering, and this is about improving information exchange between a systems engineering team. And unfortunately, systems engineering for big projects is still stuck with the documents, and we want to drag it into the 21st century to be computer-based and model-centric. We're working with Airbus Defence and Space, who are a big manufacturer of spacecraft, but we're also trying to work on really tiny spacecraft like this one here. This is a very crude model of something called a CubeSat, which is a very small spacecraft developed for universities to use and small countries to develop. So we're applying our model-based systems engineering to even down to these CubeSats.
One of the major themes of work that I'm involved in is about self-replicating machines, so machines that are capable of making all or part of themselves. And where we're taking the work now is enabling users to co-create useful designs with a 3D printer. And a key part of that is embedding design capability onto the 3D printer. So we're doing quite a bit of work with colleagues in the university around artificial intelligence, machine learning and deep learning techniques to be able to support the machine and provide on-board design direction and design reasoning.
In my group we do 3 areas of work. The first is about safety critical software. This could be software running a nuclear plant, flying a plane, trains, autonomous cars, things like that. So it really matters if it goes wrong. The second area concerns a simple question: how much should we spend on making these systems safe? But one of the members of my group has developed J-value analysis, which we hope will answer this question. The third area is about people. We're looking at methods for analysing the pressures on people in organisations, the commercial pressures, time pressures, personal pressures, which predispose them to making errors. Really, human factors has been important in nearly all of the major accidents you could name, from Chernobyl to the space shuttle disasters, Hatfield rail crash, Fukushima, even the Grenfell Tower fire recently.
My research group is involved in the systems design of bicycles and test rigs that test bicycles, particularly testing the transmission efficiency. One of our biggest achievements was to come up with a brand new type of testing of chain transmission, And basically what we do is we have a pendulum, and the pendulum swings backwards and forwards, and it's driving something like a clockwork mechanism, and within that is a chain. And once we release the pendulum, by looking at how long it takes to come to rest, we can deduce how efficient the chain is. And we were approached by Team GB to help them to design their chain drive for the Rio Olympics in 2016. Team GB won 6 gold medals and broke 2 world records. And so we were very proud to be a part of that achievement.